Hello class, welcome to Unit 9, Video 4. Today we're going to look at solving rational equations. This is day 1, but there is going to be other days of solving rational equations. So your learning target is that you can solve rational equations. Okay. So here is a little example. A music download service advertises downloads for $1 per song. The service also charges a monthly access fee of $15. If a customer downloads songs in 1 month, the bill in dollars will be 15 plus X. That should say right in there. Okay, so that's the total bill. And then to figure out the cost per song is to take it and divide by 15. Okay, so it says how many songs a person would need to download. Find how many songs a person would need to download to make the actual cost per song $1.25. So the actual cost per song is this, so we want that to be $1.25. Okay. So what we're going to do is we're going to solve. The first thing I would do is get x out of the denominator, so I'd multiply both sides by x. So we have 15 plus x equals 1.25x. Now it's just back to a simple two-step equation. I would get all my x's to one side, so I'd subtract x. So I have 15 is equal to 0.25x. And the last thing I would need to do is divide by 0.25. So 15 divided by 0.25, you type it in on your calculator, and you get x is equal to 60. So that would be 60 songs. So I would need to download 60 songs for them to cost $1.25 per song. Okay. So today we're going to look at a rational equation. We've been looking at rational expressions. Okay, so now we're going to be looking at equations. Remember, equations mean they have the equal sign. Okay, so it's any equation that contains one or more rational expressions. So the rational expression that we just solved was a rational equation. Another example would be like if I have x squared minus 5x plus 4 over x minus 4 equals 2. Okay. So let's go ahead and start solving. We're going to solve some that are a little more complex than that first example. Okay, so what you want to do when you're solving is you want to use common multiples. Okay, so to solve rational equations, you will eliminate the denominators. Okay, so that's going to make us happy. That's going to make it so we do not have fractions. So if we eliminate the denominators, you can do this by multiplying both sides of the equation by the least common multiple of the denominators. Okay, the least common multiple of the denominators is then called the least common denominator, the LCD, which is we've already been finding the LCM of the denominators, so that's the LCD. Okay, we did that in Unit 9, Notes 2. So let's look at example 2. We want to solve. So we need to find the LCD, which is the LCM. This one's actually pretty easy to see right off the bat. Okay, if I want to make all my denominators the same, my LCD, my least common denominator, could make them all be 5x. Okay, so we need to take and multiply both sides by 5x. Okay, if you do one thing on the equation and you do it to the other, then that's how you would solve this. So just make sure you have the difference between your solving methods for expressions versus equations. Okay, so if this was an expression and we were not looking at this side, you'd have to get a least common denominator and then subtract them. Okay, now we're going to get rid of the denominators and solve. So there is a difference. Okay, so when you do this, your LCD, you multiply it times all your numerators. So I'd have 5x over 5 minus, and just leave it as 2 times 5x over 5x equals 5x over x. The goal of this is that your denominator should disappear. If it doesn't, you picked the wrong LCD. 5's would cancel, 5x will cancel here, and my x's will cancel. So really I have x minus 2 is equal to 5. And so I'd add 2, so x is equal to 7. Okay, so I think this is my answer, but the nice thing is you can always check your answers when you're solving an equation. So I would recommend checking, especially on your quiz. So I'd have 1 over 5 minus 2 over 5 times 7 is 35. Does that equal 1 over 7? Okay, so if I want to check this, you can type it on your calculator to see if it's the same, or I could get a common denominator, 35, so times 7. So I have 7 over 35 minus 2 over 35. Does that equal 1/7? 7 minus 2 is 5 over 35. 5 over 35 simplifies to 1/7, so yes, this is my answer for sure. Okay, that is example 2. Let's go ahead and look at example 3. Okay, looking at this one, what could I make all of my denominators be? This one, currently, this 2 is over 1. So I could make all of them. They're for sure going to have an x, and they have to have a 2. So I'm going to take everything on the left-hand side and multiply it by 2x, and everything on the other side and multiply it by 2x. Okay. When I take this, I'm just going to write it all out. So I'd have 2x times x minus 3 over 2x plus 9 times 2x over x equals 2 times 2x. Now let's simplify. Once again, remember those denominators should cancel. If they don't, we did something wrong. The x's will cancel, and that's it. So I have x minus 3 plus 9 equals 2 times 2 is 4x. Combining these two, I would have x plus 6 equals 4x. I'm going to move the x to the other side. So I have 6 equals 3x, and if I divide by 3, x is equal to 2. Okay. Like I said before, you can always go and check. Okay, so I would plug in a 2 for all my x's. So I'd have 2 minus 3 over 2 times 2 plus 9 over 2. We want to know, does that equal 2? 2 minus 3 would give me negative 1 over 4 plus 9 over 2. Does that equal 2? Okay, well, if I get a common denominator, be 2, so I'd multiply this by 2 and this by 2. You could also type it in your calculator and check. Plus 18 over 4. 1, this would give me 17 over 4. Did I make a mistake somewhere? It looks like I did. What did I do wrong? Oh, does everybody see where I went wrong? Okay, so this is why it's important that we check. Okay, so I'm going to check. I forgot to take 9 times 2, which would make this 18. It's going to change things. So, negative 3 plus 18 is 15. Okay, I'd still subtract the x, but then this would change. So, all right, so I have 15 is equal to 3x, divide by 3. So x is equal to 5. That will make a big difference. So see how nice it is to check your work? Everybody makes little mistakes every once in a while. So especially until you get the hang of it, I would recommend checking it. All right, let's go and plug it in. So we would have 5 minus 3 over 2 times 5 plus 9 over 5. We want to know, does that equal 2? This gives me 2 over 10 plus 9 over 5. This reduces to 1 over 5 plus 9 over 5. This would be 1 plus 9 is 10 over 5. Does that equal 2? Yes, it does. So there is my right answer. Okay. So that's example 3. If you have any questions, let me know. Otherwise, we're going to move on. All right, now I'm looking at this one. This one might not be as easy of a common denominator to find. So what I would recommend is let's just do our little factor tree. Okay, 28 breaks down into 2 times 14. So I'm going to find the LCD down here. So 28 is 2 times 14, which is 2 times 7. We would have a z plus 2 for sure, and then 4 breaks down into 2 times 2. So my LCD, there's 2 2's, times 7 times z plus 2. 2 times 2 is 4, 4 times 7 is 28. So my LCD is 28 z plus 2. So I take that and multiply that on both sides. Okay, so I would have 28 z plus 2 on this side and 28 z plus 2 on this side. Okay, some of you might be getting the hang of this, and you may not need to write down this first step and show the canceling. I'm going to do it. Let's go 2 more times, and then after that I might stop. Okay, so I'm going to do this. So I'm going to write it out in the numerator. So I would have 28 z plus 2 times 9 all over 28 plus 28 times z plus 2 times 3 all over z plus 2 equals the last one. getting cramped. 28z plus 2 times 3 all over 4. Okay, this is a 3. Let's cancel what can be canceled. 28s will cancel. Okay, z plus 2's will cancel, and 28 divided by 4 is 7, so those will cancel. Denominators are gone. Let's simplify. So I need to distribute my 9. So I would have 9z plus 18 plus 28 times 3. 28 times 3 is 84. Equals, this is 7 times 3, which is 21. So we're going to distribute 21 together. 21. So that would be, that's hard to see, 21. There you go. 21z plus 21 times 2, so 42. Now, combining like terms. Hopefully you have a little more room than I do. 18 plus 84 gives me 102, so I have 9z plus 102 equals 21z plus 42. I would get all my z's to one side, and I want to keep them positive, so I'm going to subtract 9z. So 21 minus 9 gives you 12z, so I have 102 equals 9z plus 42. I would subtract 42 from both sides. 102 minus 42 is 60 equals 12z, and then I would divide both sides by 12. So z is equal to 5. Okay. And we should always check to make sure we did it correctly. So I would have 9 over 28 plus 3 over 5 plus 2, so 7. Does that equal 3 over 4? Okay. I'm going to leave it up to you. If you type this into your calculator, guess what you get? 3 over 4. Okay. That is example 4. Let's go ahead and look at example 5. Okay. Least common multiple. So let's just look at our numbers. We have 6 and 2. Okay. What can I make both them be? I can make them both be 6. So I know for sure my LCD is going to be 6, and then I'm going to have an x minus 2. Okay, so left-hand side I take times 6 x minus 2, and the right-hand side I take times 6 x minus 2. Okay, so I would have 5 times 6 times x minus 2 all over 6 plus 2 times 6 times x plus 2. Why did I write x plus 2? X minus 2 all over x minus 2 equals 1 times 6. I'm just going to write 6x minus 2 all over 2. And let's simplify. The 6's cancel. The x minus 2's cancel. 6 divided by 2 is 3. Now distribute. We would have 5x minus 10 plus 12 equals 3x minus 6. Combining like terms on the left-hand side, I have this. Now I would subtract 3x from both sides because I want to keep my x's positive, minus 2. So I would have 2x is equal to negative 8. So when I divide, x is equal to negative 4. Okay. Now let's do our check. Okay. It doesn't have to be as much work as I've been writing out, but it is so important to check. So we want to see is 5 over 6, so 5 divided by 6, plus 2 divided by, I'm going to put in parentheses, it'd be negative 4 minus 2. Okay, does that equal 0.5? Yes, it does, so we did the check, and it all works out. So I have the right answer. Okay, number 6. Let's go ahead and look at that one. My numbers are 12 and 48. Okay, so my LCD, can I multiply 12 to be 48? Yes, so it's 48. And then I have to add that x minus 4. Okay, so 48 times x minus 4, multiply it on both sides. All right, so if I do that, I'm not going to write it out this time. I'm going to take a little bit of a shortcut. So if I take this times my numerator, I'm still going to have 7. Okay, then I'm going to have 48 divided by 12. 48 divided by 12 is 4, and then I'm still going to have x minus 4. Plus, now I'm moving on to my next one. If I take this times here, what's going to cancel? The x minus 4. So I'm going to have 48 times 9 equals, on the other side, when I take this times this, my 48s will cancel, and I'll have 55 times x minus 4. If you need to still write it out like I did before, that's fine, but I did not that time. Okay, now I have, this is really 28, so I'm going to distribute that. So I have 28 times x, so I have 28x, minus 28 times 4 is 112, plus 48 times 9 is 432. That equals 55x, and then 55 times 4 is minus 220. Combining my like terms, negative 112 plus 432, I'm going to get 28x plus 320 is equal to 55x minus 220. I'm going to get all my x's to one side, so I'm going to move it to the bigger one, keep it positive. So those will cancel, so that means I'm going to add 220 to the other side. So what I have, 540 equals 55 minus 28x is 27x. I would divide and I get x is equal to, let's check that one out. I'm not sure. 540 divided by 27. That gives me 20. So x is equal to 20. Okay, let's do our check. Pull up our calculator. So I would have 7 over 12 plus 9 divided by parentheses 20 minus 4, which I guess you could figure out in your head if you wanted to. Enter. Okay, and then I'm going to put in a fraction. Math, frac, enter, 55 over 48. So it checks out. All right, we have one last problem. I would really like for you to try it on your own. Pause the video, try it, and then come back. All right, so if I look at 7, LCD for this one. Okay, I have 4 and 24 on my numbers. Can I multiply 4 to be 24? Yes, I can. So I would have 24, and then I'm going to have 3 minus x. So on each side, 24 times 3 minus x. And on this side, 24 times 3 minus x. Okay, I'm not going to write it all out, okay, like I did before. So I'm going to take it, when I multiply this on my numerator, who's going to cancel? My 24s. So I will have 5 times 3 minus x, plus, when I take this times my second fraction, the 3 minus x's will cancel. So I'll still have 24 times 2 equals, when I do this here, well, it's times 1. 24 divided by 4 is 6. Times 3 minus x. This will give me 15 minus 5x plus 48 equals 18 minus 6x. I'm going to combine these like terms. I have negative 5x. This is going to give me 63 equals 18 minus 6x. Okay, going to bring the smaller to the larger for my x's. So actually negative 6 is the smaller one. And that means I'm going to subtract 63. So x is equal to 18 minus 63, which is negative 45. Last step to do, plug it into our calculator and check. So we have 5 divided by 24 plus 2 divided by 3 minus a negative 45. Does that equal 0.25? Yes, it does, so we are done. Okay, so that is it for solving rational equations. If you have any questions, please let me know. Otherwise, have a great day, and I'll talk to you later.